It's been a long road to modern synthesizers like the ultra-compact Uno Synth Pro. In the mid-1970s, synthesizers were built using mostly discrete electronics. This made them big, expensive, and often unreliable, especially in the case of the early polyphonic synthesizer market, with instruments like the Polymoog and the Oberheim 4-voice. It was a Silicon Valley company called Solid State Music, or SSM for short, that created the first ASIC designs, application-specific integrated circuit, for music synthesizers. These were microchips that could replace whole swaths of circuits and greatly simplify a product design and reduce its manufacturing cost. This was a sea change in synthesizer development. It reduced both the size and the price of polyphonic instruments in particular, and it also allowed for more features to be included to meet musicians' demands. We have here with us two of the SSM team members, Dave Rossum and Dan Parks. Dave is also notably the founder of Emu Systems, first a maker of modular analog synthesizers, and then a pioneer of digital sampling with the legendary Emulator series of products. Dave was responsible for the groundbreaking Emulator digital sampling keyboard and the SP12 and SP1200 digital drum machine. Dave and Dan have recently begun making synthesizer chips again as SSI, Sound Semiconductor Incorporated, carrying on the legacy they began over 45 years ago. So Dave and Dan, thanks for joining us. Great to have you guys here.
Good to be here.
I want to talk about the very beginnings of SSM. As I understand the story, Dave, Ron Dow contacted you about a VCA chip that he was looking to sell to Emu Systems to use in your modular synthesizers. You had some slightly different requirements, and you guys ended up making some changes to the chip, and that led you to make other chips, and that was very much the beginning of SSM. Tell us about that.
I first met Ron Dow. He came to our apartment that Emu was operating, 2455 Homestead Road, number 59, and just showed up on the doorstep saying, I've got a great idea for a chip. I learned that he worked at a company called XR, which we knew, it's an analog chip company, in the early 70s. And this was probably, I'm guessing, about 1974. It might even have been 73. And at that point, Ron just had the idea. SSM did not exist. Ron was interested in electronic music. I think he found us through Electronauts newsletter, which was published by Bernie Hutchins back in Ithaca, New York, and I was a regular contributor. Ron wanted to know if Emu would be interested in paying I think it was about a $3,000 fee to get the prototypes integrated for his VCA that he had invented. You know, being engineers, of course, we hit it off, and being interested in music and electronic music as well. Back then, the process that XR had and the other company in the same business of making semi-custom analog chips was InterDesign. The process that they had for building those chips was what's called a 24-volt process, which meant that the power supplies could not exceed plus or minus 12 volts. And the Emu modular system, which was in production at the time, used 15-volt supplies. I told him at the time, we weren't interested in that kind of a product just because we couldn't use it in our product line because of the power supply issue. And he said, yeah, but that's the only process they have. So I said, well, if they ever come out with a 36-volt process compatible with 15-volt supplies, I'd be really interested, but we got to pass for now. The other thing I didn't mention to him, that in synthesizers, the specs were not terribly important, and we already had working VCAs using a really cheap chip called the CA3080. And those chips cost 20 or 25 cents a piece at the time, and even after paying the $3,000 integration fee, I was sure that these VCAs were going to cost a couple or $3 a piece. So it would have been a price increase for not really much of a benefit for our modular product. Didn't hear from Ron for a long time. In fact, and this is kind of a fun part of the story, the next thing I heard about this was a guy named Doug Curtis. Again, showed up on the doorstep of Emu at Homestead Road, and he just won a contest sponsored by InterDesign, the other company that made these chips, and won it with a chip that was designed to be a building block for electronic music. And he wanted to know if Emu would be a customer for his part, or maybe even design further parts together. But we ran into the same problem, that we couldn't use the part because of the power supply. So Doug went off to get his award at InterDesign, and they offered him a job, and he went to work at InterDesign. Now, the SSM story, Ron, after coming to us, went to other places he found, including a company that existed called SSM. And it was run by a guy named John Burgoon and the Burgoon family. They had one music product that I knew about. They might have had others, but the only one I ever heard about was a board that went into S100 style home computers that had a waveform generator RAM. And so it would spit out waveforms with a shape of your choosing, because you could write numbers, 8-bit numbers, into this thing, and it would spit them out cyclically on an 8-bit DAC, and you could get what turns out to be not very good synthesis stuff, because raw waveforms, as we all know, don't sound that great. You really have to dynamically filter them, and there was no capability of doing that. Nonetheless, the company's name was SSM, for Solid State Music, and they were primarily in the business of selling surplus parts. You could buy test rejects from the IC companies. They still worked, they just didn't work to full spec, and so if you remarked them, you could sell them. And I think that was the Burgoon's main business. But they partnered with Ron and created the chip, the SSM 2000, and that was Ron's first VCA. I don't think it ever sold very much at all. It's actually kind of hard to find information about it. If you go look for it on the internet, it exists, but I'm not even sure that you can find a spec sheet for it. Sometime in the, I'm guessing 1975, 76 era, InterDesign and XR both came out with the Monochip D was the InterDesign name for it, but it was the 36-volt part that we've been waiting for. And Ron came running back to Emu and said, "Dave, we've got a 36-volt part." And okay, now I'm interested. Ron, at the time, had realized there was an improvement to be made on his SSM 2000 VCA, and so he had the idea for what became the SSM 2020. And my concept was build the whole line of synthesizer chips. So build an oscillator, which ultimately became the SSM 2030, a filter using the filter design that I had invented for Tom Oberheim. Tom Oberheim had said, how do you make a filter out of a CA3080? And I literally, on a napkin over lunch, drew a schematic. Tom said, "Did you just invent that?" I said, "Yeah, I guess I did." He said, "Do you think we could get a patent on it?" I said, "I don't know anything about patents," but we did. We got a patent on that filter, so the SSM 2040 was patented. And then an envelope generator, the SSM 2050. Ron took the lead on the SSM 2020. The 2040 was entirely my design. Ron taught me a ton about how to design integrated circuits. I had never done one of those before, but I turned out to be a fast learner. We collaborated on the SSM 2030, and I think I did most, if not all, of the 2050. And over the next year and a half, the Burgoons paid for those to be integrated. Sometime in early 78 or maybe late 77, we had a complete line of synthesizer chips. And that's the beginning of SSM and the whole family of SSM chips.
You started off with the VCA chip, and then of course you went on to design chips for the rest of the synthesizer, the VCO, the VCF, the envelope generator, etc. Was this the plan all along, or did you just make one chip after another based on specific needs you had?
Ron was interested in more chips from the very beginning. When he came with the SSM 2000, it wasn't just this is a one-off. It's like, let's build chips for synthesizers. So when he came back with the 36-volt process and the SSM 2020, I think in both of our minds, it was let's make a family of chips for synthesizers. But there's another piece to that story, which is that while Emu was in the business of modular synthesizers, you sold a modular synthesizer company like Emu sold one, if we were lucky, every month or two, something like that. They were big, expensive creatures, and a lot of the expense was the cabinet, the power supplies, all the hardware. The electronics were really a minor cost on that. So developing chips where you crank them out in the tens of thousands, and we were selling, tens of synthesizers, maybe hundreds of modules a year, and the chips really didn't make much sense. My degree from college is in molecular biology, and people wonder how on earth did I end up in synthesizers. But my interest in biology when I got my degree from Caltech was in applying computers to biology. So I took a bunch of computer courses at Caltech and was very interested in how computers work. So when the very beginning of homebrew computers and things like that started, our first employee at Emu Systems, a guy named Ed Rudnick, was working as a technician at Intel at the time, and he pilfered Intel 8080 from Intel, and the chips cost $300 in those days for one Z80. Brought it over to EMU, and I built it up into an actual computer. Eventually, we replaced the 8080 with a Z80 in that computer, but we used the computer we'd built as the accounting and inventory system. We did all of our text editing on it for our spec sheets and so on, and marketing literature at EMU. It was our general purpose computer. So we were a little tiny company with a very nice computer. 1971-72, when EMU was first starting, all synthesizers were monophonic or maybe duophonic, that you could get one or two notes off the keyboard. And there was a lot of talk about a polyphonic keyboard. Everybody was doing it was going at it on the wrong approach, because the monophonic keyboard played the lowest note that you held if you held several notes. And the duophonic keyboard played the lowest and highest notes. So everyone was thinking, well, a polyphonic keyboard, you'd have one voice for the lowest note, one voice for the next lowest note, and so on up to the highest note you were playing. And I realized that just wouldn't work, and that instead you needed essentially computer logic to have it instead do the first voice, one note played, and the second note played, and the third note played. So I worked out all the logic for this and actually built out of TTL the world's first polyphonic keyboard for a modular synthesizer. And EMU sold that starting, I think we started advertising it in 74, early 75, and sold the first one to Leon Russell. Then later, like I said, just before Ron came, we realized that the Z80 computer was now cheap enough you could use it in a product. And in early 77, we announced, having been working on it for some time, the first computer-based product in electronic music, the microprocessor keyboard and sequencer. At that time, we realized that there was going to be a different market for polyphonic synthesizers that had to now be a lot cheaper. And the expensive electronics we've been putting in the modular system, because the electronics price didn't matter very much, suddenly that was a changing game. And to do that, you would want to have chips. So the vision of the SSM chips was to be able to build polyphonic synthesizers. So that was what really fueled the fire of let's get going on this entire family of chips, and brought about the SSM line.
Looking back, the Prophet 5 seems like a real milestone in semiconductor-based synthesizer design. How closely did you work with Dave Smith on this instrument?
We met Dave Smith maybe 73, maybe 75. Dave had gone to San Jose State, studied electrical engineering, and loved music, got himself a Mini Moog, and wanted a sequencer. So he built himself a sequencer, and then realized, what I'd like to do is have a business. So he created a business to sell sequencers, hence the name Sequential Circuit. One of the pieces that you got to have for a sequencer is the fundamental clock, the oscillator that makes it step from step to step. And Dave didn't know much analog electronics. And he heard of this company called Emu Systems, so he came over to visit. I think it was actually my business partner at Emu, Scott Wedge, that said, hey, Dave, why don't we sell you one of our oscillators to be in your sequencer, and you can just buy them. We'll give you a great price on them because you're going to buy them as an OEM. The first sequential products had Emu oscillators in them. And as time went on and Dave expanded his product line, he'd come over and visit. We'd come up with different I'd design analog circuits for him. He was a buddy. I think he needed matched transistors sometimes for some of his products, and so we'd let him use our process for selecting matched transistors and so on. All kinds of different things. So we were really pretty close. And when the SSM chipset came out, actually, let me go back, because this is a fun story that very few people know, including, until 2 years ago, me. As a matter of fact, 1 year ago, me. So, as I mentioned, Dave Smith went to San Jose State. At January 2020 NAMM, the last NAMM before COVID, I went up to have drinks and hors d'oeuvres at Sequential's hospitality suite. And there was Dave holding court, and he has a seat next to him for me, and we start talking. We discover that we both not only grew up in San Jose, we grew up in the same neighborhood, Willow Glen. Not only that, but his parents had him go to the Catholic high school, Bellarmine, because it was a private school. But if he hadn't gone to that, we would have gone to the same high school in the same class. We would have been classmates. There is this kind of relationship that neither of us had ever figured out existed until 2020.
Wow.
We were just laughing over that. It was really, really fun.
Amazing.
Anyway, so back to the beginning of the Prophet 5. With the SSM chips coming out, Emu's plan was to build a very high-end, very sophisticated computer-controlled analog synthesizer. We actually did build that beast. It was called the Audity, AUDITY, and showed it at the 1980 AES show. Tom Oberheim, another good friend. Tom used our polyphonic keyboard in the Oberheim 4 and 8 voice. I had forgotten, but I recently was reminded that I actually helped design the Oberheim expander module. The oscillator in that is a Dave Rawson design as well. So Tom had advised us about Emu. You don't want to get into NAMM shows and consumer electronics. He said, like the kindly old Geppetto said to Poke, stay wood, kids, stay wood. And so our plan was to be suppliers of technology, not have to go into the rough and tumble world of real consumer music products. Again, my business partner, Scott Wedge, put it most honestly. He said, Dave wanted to build a synthesizer, and Scott said, build a polyphonic mini-moog. You can use the SSM chips, use our polyphonic keyboard, which is now implemented in a microprocessor. And Dave says, yeah, I can do microprocessors, and I can do digital stuff. But how am I going to design the synthesizer voice? Well, I said, well, I can do that for you. The Prophet was a collaboration. The SSM chips were existent before the concept of the Prophet really was brought to any kind of reality. Dave came over and used this Z80 computer that I was talking about, the one that we did our accounting on. All the original Prophet 5 software was designed by Dave at Emu using our Z80 computer. I did the analog design of the original Prophet 5. That was all my design. For that, Emu got a royalty, and then we're also getting a little royalty from the SSM chips. So much more from the rest of the design, because we really collaborated so much in the original Prophet 5, Rev 1, and Rev 2.
So for myself and so many others, the SSM chips were always regarded as sounding superior to the Curtis chips. For example, a Rev 1 or Rev 2 Prophet 5 will sell for double what a Rev 3 Prophet 5 will sell for today on the vintage market. And then somehow to validate this, last year, Dave Smith released the Rev 4 of the Prophet 5. And to differentiate the Rev 4 from the old Rev 3, he added your new SSI filter chip in addition to the classic Curtis filter chip that's in the Rev 3. So you could basically get the Rev 1 and 2 sound of the classic SSM chips and then the Rev 3 sound of the Curtis chip. What's your impression of this?
So first of all, I have to say that Doug was always a friend, very much a gentleman. He was just a wonderful guy. I used Curtis chips and Emu products as well as SSM chips. While there certainly was animosity that's long since been resolved when Sequential shifted over to using the Curtis chips, one of the things that, if you knew Doug, you would know this was true, was he would never consider expropriating somebody else's intellectual property. I think one of the reasons that his filters sounded quite different from ours was that he just avoided anything that could have been at all similar to the chips that I had designed, and came up with his own ways of doing filters. And when you do that, they're going to have inherent differences. I'm sure also because Doug was a brilliant guy. I have no question that had he had the incentives first, he probably could have come up with the designs that I did, and probably the same the other way around. We sort of got there first with the designs that had character in the filter. And so absolutely there is a difference in the sound of the filters. We all knew that. Again, I'll be blunt, that the filter I loved was the SSM 2044. That's the sound that I really like, and that I always considered the 2040 a little bit inferior to that. One of the things I love about musicians is that they discover where to use a sound, and the SSM 2040 fits into more places in modern music. A lot of people just absolutely love that sound. Plus, there are more ways of tweaking the 2040 to get it to sound a little different by just external analog tricks, and I think people are doing that as well. So absolutely, the filters sound different, and the 2040 has a really interesting sound. I had some friends analyze why that's the case and come up with some good understandings with that all fit with the way the chip works. Dave let me in early on the fact that he was going to do the Prophet 4 and what he was going to do, and I told him that's a really cool idea. And I think it's done very well for sequential. I'm really delighted to see that. Doug passed away in, was it 2000? And a great loss to the synth community because he was such a brilliant and enthusiastic guy. And his wife Mary has tried to keep the business alive and so on. And so I'm pleased that Mary and Dave have been able to work together. It's become kind of a long-lost family again, which is really neat.
I worked with Keith Barr at Alesis, who designed the custom oscillator and filter chips for the Andromeda. And of course, everyone's familiar with the sound of the Curtis chips. But somehow your SSM chips, and of course the new SSI chips that you've designed, really have their own sonic mojo. So what is it about these chips that makes them sound so special? What's in your secret sauce?
I think the blunt answer is it's dumb luck. As a musical engineer, you explore ideas. I have a design style. It tends to be very simple. I have a love of inventing, so I love to invent new circuit topologies that I haven't seen before and maybe nobody's seen before. You never really know until a part is in production how it's going to go into the music, because it's the musicians who do the magic. They're the ones that really make the sound into sound with a small letter into the sound with a capital letter. That's something I can't do. I'm not a musician. I do my best to give musicians tools that they can use. Then I have to just let them go and just see where they go. So, yeah, I'm a pretty good electrical designer, and my work right now, I'm a technical fellow at Universal Audio, and I call myself the tame analog designer there because there aren't that many of us analog designers left. The digital world has so much eclipsed the analog. That's a lot of fun. It's why I'm still working at my age.
I think Dave sold himself just a little bit short there because he is a great analog designer, but he's one of the few people I know that can equally transition between digital DSP, pure DSP designs, and analog, and kind of everything in between, whether it be interfacing and so on. So he's really got this broad skill set that you'd be very hard pressed to find elsewhere. Going back to the SSM days, one of the things that really is not broadly known about the SSM and the Curtis chips, and Dave referred to XR and InterDesign, these were semi-custom arrays. So they're kind of like the equivalent in analog of a gate array, where it was there were these various models of chips that had, in any given model, a certain number of transistor types, and components and their arrangement, the geometries. It was all fixed. And the only thing that you really did that was custom was the metal interconnection. So by interconnecting the metal, you would create a unique IC. And it's amazing with those severe constraints what both Dave and Ron Dow did, as well as Doug Curtis, with these semi-custom chips that, today have become so legendary.
Dave, in addition to analog synth technology, you've been quite a pioneer in digital sampling technology. Of course, you're known for your emulator series of samplers, and of course, the SP12 and SP1200 drum machines. These combined sample playback and, of course, analog filtering as well. Can you tell us a little bit about these products?
Well, the emulator itself, the Emulator 1, came about because of this challenge we had with sequential and the Rev 3 Prophet, which caught us by surprise. And as I said, there was animosity around it that's been resolved. I don't need to talk about that anymore, other than to just say we're all good friends again. And I think ultimately the music world really profited from those difficulties, so I can't say they were all that bad. We went from being a technology company, which is what we wanted to do, into needing a real product. Some clues we got at that 1980 audio engineering show down in Los Angeles told us that sampling was the direction. So that was the necessity that was the mother of invention of the Emulator 1, which was really the first affordable sampler. Sampling itself turned out to be a very interesting technology. It marries with the SSM chips, ultimately including Curtis chips as well in various versions of the emulator, but it was the Emulator 2 that really put EMU on the map. And that was the marriage of a sampler with the analog synthesizer. I'd love to say that that was my brilliant invention, but I really have to tip my hat to Jim Cooper down in LA, one of folks that worked with Tom Oberheim there, J.L. Cooper.
Sure.
And he used to make a mod for the Emulator 1 that added the SSM chips onto it. That was, its popularity is what absolutely cinched the direction that the Emulator 2 would go. And then ultimately, the additional emulator families and spin-offs like the Emacs used analog chips for a while until we could go entirely digital, which it was really the E3X was the first place where we actually use my digital filters instead of my analog filters. The SP12 is another very interesting story, really a triumph of how the limitations of analog design and cost can allow the musicians to take the world in a different direction. The SP12 was designed as a follow-on to our drumulator. The drumulator was 8-bit and used companding technology. It was a pretty raspy sound. And we knew Roger Lynn was working on what became the Lynn 9000, which would be a 16-bit, very high-fidelity drum machine with a degree of modularity and so on. And so we chose to instead go for the lower price point, only went to 12 bits with the SP12, but felt with our experience with the Emulator 1 and 2 that user sampling was terribly important. Also, we needed pitch shifting, but we couldn't afford to do the very clean pitch shifting that was done in the emulator series. So we instead did something called drop sample pitch shifting, which again is raspy and kind of dirty sounding. An instrument that I'm very proud of, but I'm more proud of what people have done with that instrument because it really has created an entirely new genre of the hip-hop world. Began with that SP12 sound and the user samples and things like that. For a non-musician like me who loves music and loves the idea of musicianship but can't do it himself, it is just such a wonderful thing to have had one of my instruments spur on a new genre. I mean, I think that really is the thing that I'm most proud of in terms of all the instruments that I've done.
And now over to you, Dan. Can you tell us a little bit about how you got involved with SSM?
I was gigging through college and got both bachelor and master's degrees, kind of put my parents into shock by going on the road with a disco band, so that really dates me. And I spent about a half a year in Hawaii playing music, and I kind of realized that was not exactly what I wanted to spend my career doing. So I came back home to the Bay Area, and I had come to the conclusion that I wanted to be somehow connected with the music business, whether it was publishing, recording, products or whatever. And I limited things a little bit more by not wanting to leave the Bay Area. So I just started, kind of hitting the dirt. I tried to get a job at Sequential Circuit. I tried getting a job at Emu. At least I called over there on Broadway in Santa Cruz at the time. And I think it was Marco that answered. And he said, well, yeah, we don't really need, like a marketing guy. But, there's somebody here that might need somebody. And it turned out Ron Dow was over there at the day. And they were just looking, SSM was a really small outfit, a couple of people in an office in Santa Clara. So I ultimately got involved with SSM. Went through a very interesting 8 years. I think that's when my business education actually started. Ron Dow, my partner of those years, a wonderfully quirky guy. Unfortunately, we lost him in 2012. I did help bring SSM to a successful conclusion, I'd like to say, in 1988 when we were acquired by Precision Monolithics. And then Precision Monolithics was acquired 2 years later by Analog Devices. And those are, legitimate large semiconductor companies. They gave us really a lot of opportunities that we didn't have as SSM in terms of manufacturing, process capability, sales force, international presence, and so on. But at the same time, they weren't very interested in the so-called prosumer market, as I'd call it. They wanted to be in the consumer markets, so do things like, hi-fi, PC audio, automotive, where the numbers are. And let's face it, the semiconductor business is a volume-based market. I ended up having a stint over at National Semiconductor once I heard they were reforming their legendary audio group, and I thought that would be the dream job. So I was over there about 3 years and realized it wasn't a dream job because I kept working for progressively larger companies. And I really wanted to, get back to an entrepreneurial environment. And as it turns out, it had nothing to do with the semiconductor industry. I started a business making tools for motorcyclists. And in the mid-90s, left the semiconductor industry. Never thought I'd have anything to do with the semiconductor industry again. The tool business I still have to this day. We eventually brought on tools for musicians, which we still have that part of the business.
And Dan, synth enthusiasts like myself rejoiced a couple of years ago when we heard that you and Dave had started SSI, basically taking the legacy of SSM and putting the band back together. Tell us the story behind this.
The cool thing about circling back from a different direction into the music products business is I was able to reconnect with a lot of my old friends from the SSM days, and one of them was Dave. We reconnected around 2016 or so, I think it was, at a trade show. And at about the same time, I mentioned I was a bass player, I got interested in synthesizer bass. I wanted to start playing synth bass. And I was kind of shocked, since I had not been paying attention, that there'd been this huge renaissance of analog synthesizers. And it just kind of occurred to me that there would be an opportunity there. And I always felt like I had some unfinished business in that field. So I contacted Dave, and there was pretty much zero hesitation out of Dave about, yeah, this is a really cool idea. And I mean, we had any idea how we were going to pull this off on the supply chain side, about putting together a team. But it surprisingly came together quite easily. Our first chip was an update to the SSM 2044, the ladder filter that he referred to as the SSI 2144. And it coincided correctly with Dave Smith's Prophet X, because he wanted a filter chip for that. So the timing was really good in that regard. And as you suggested, there has been a great reception for this enterprise. So in addition to Dave, we have another brilliant engineer named Derek Bowers, who I worked with in Analog Devices for many years. He also was a contributor at SSM, and he's actually the one that designed the SSI 2164, which is in the Uno Pro. And that was an update to an Analog Devices chip since discontinued called the SSM 2164. Derek has also since developed the first new VCO chip in decades, which is our SSI 2130, and we have a derivative of that we're about to announce. And then Dave, we compelled him to keep working on filter chips. And he actually collaborated a little bit with Derek on the update to the SSM 2040 in the SSI 2140 by adding some temperature compensation schemes, adding some other features like the QVCA. And so, because, one of the advantage for sound semiconductor, unlike the SSM days where we were constrained by those semi-custom arrays, we're doing full custom chips. So, we can, specify transistor geometries, placement, and so on, that's optimized for any given design. We have dual layer metal. We're on, 6-inch wafers. It's thoroughly modern, yet mature process that we're designing our chips on. So, we've got 6 ICs in production now. We've got more in development, one big project that Dave and Derek are collaborating on, and some other stuff that's in the pipeline. Fortunately, we have no shortage of ideas on what we can be doing.
So, as I mentioned when we were starting up Rossum Electro in 2015, we dropped by Dan's Groove Tools booth at NAMM and said hi, just because he was an old friend. We hadn't seen him for a long time. And, then just, I think, probably briefly broached the subject of would there be a possibility of resurrecting SSM and the chips. Rossum Electro, as soon as we began to exist, we get emails. Well, no longer because we've done it, but for the the next many months, we were getting how about you go into the business of making the SSM chips again? And it didn't make any sense for Rossum Electro. We want to be making instruments rather than chips. But when Dan got in touch, that was why it was such a no-brainer to say, of course, is because we knew the demand was there in the Eurorack market, and also with some of our professional contacts. People were talking about it, and so the idea was definitely out there.
And in fact, those requests continue to come in for bringing back, the whole SSM library of the envelope generator chips and so on. But I think we decided early on that rather than bringing back chips from decades ago with the technology for terms of process and manufacturing technology and 2 really, really great chip designers, that's kind of a waste. I think it's a much better thing to design ICs for, now 2021. Well, some of our first products have been updates to SSM chips from the past. They actually did bring new performance and features. In the case of the VCO, that was a complete new, clean sheet of paper design. So that's really our focus, is to develop new ICs rather than, look too closely back to things that were done back in the 70s and 80s.
But you have the 2140 and the 2144, so you've met that need already.
Right, and both of those are not just the 2040 and the 2044. Right. They the 2144 was not a huge change to the SSM 2044 because it was more of a proof of concept. I mean, Dave was able to optimize noise through transistor geometries, improve control feed through, and make some incremental improvements. But that really was the test mule for the enterprise to see if we actually could get the first batch of silicon and it actually functioned as a filter chip. But the 2140 went a lot farther, I think, than the 2040. And even the 2164, the quad VCA, there's no point of just rehashing a design from 20 years prior. So there was some improvements made to it.
One of the wonderful things about SSI for me is the opportunity to work with our other designer, Derek Bowers. Derek is one of the most brilliant people I've ever met, and he spent his career in IC design. So I'm a mere piker compared to him. Now, he argues with that a little bit. We get along very well. For me, the involvement with SSI is also an opportunity for me to learn more about IC design from Derek, and for the two of us to brainstorm and collaborate together. That's, of course, the most fun, is when we take both of our talents. I can't emphasize enough how fortunate we are to have somebody who is as experienced as Derek and who loves electronic music and pushing the state of the art forward. This has been his passion since he was a teenager, and he feels so lucky to have had a career that involved electronic music, and now once again he gets to be a pioneer pushing the limits forward again. And so we're having a really fun time pushing the limits and bringing these tools for musicians.
So one of the beauties of sound semiconductor is, you can tell by looking at us, we're past our prime perhaps, but that also means that we're able to get to a point in our career where we're not dependent upon this enterprise to pay the bills or pay a mortgage. What we kind of decided early on was to self-fund it, not have outside investors that we'd have to answer to, so that we can continue to focus on what we want to do. So there won't be that pressure to do chips for flat panel televisions or for mobile devices. The slogan is ICs for music creation. So I would say pretty much anything that you might find in a NAMM show or an AES show, that's the kind of products that we would like to develop ICs for.
Dave, in your experience as a product designer, of course, in addition to using great chips, great semiconductors, what's also needed to make a great synthesizer?
Great synthesizer is also a pretty broad term.
It's deliberately vague.
Right. One thing you say is, a great synthesizer is a classic. The Prophet 5, the Emulator 2, those are classic synths. So is the Yamaha DX7. All of them have to be very well engineered. You've got to not only have the sound path capable of creating the sounds, but you've got to be able to have the control structure, everything about the instrument has to allow those to be accessible to the musician. But I think you also need to be able to allow the musician to exercise his creativity, to get a sound that is unique to the individual and to the song that's being performed. I said it before, there's some dumb luck involved too, that the sound has to be right for the time. The SP1200 was the right sound at the right time to be able to inspire a new generation of artists who many of them never even realized they were artists until they heard that sound and it spoke to them. I don't think you can plan to make a classic synth, that it sort of happens, but you certainly can engineer things so that they are capable of being classic synths. Or you could say that a great synth is a successful synth. And that's when, cost-effective engineering comes into play. Be flexible enough in your engineering that you can look at, okay, what is the price of this and what does it bring to the musician so I can give them the greatest value for their dollar. All kinds of levels on which that game can be played, some of which are in other parts of the company besides engineering, have to be able to drive the right prices, get the mechanical portions of things and so on. Really drive that and make those synths that, people buy them because, boy, how can I not spend the money to get that sound? For me, the goal is the new synth. That this is what I love to engineer, is to be able to bring musicians new tools to be able to make sounds they haven't heard before, or if they've heard them before, give them new control over it. In addition to making the sound, you have to think about how is that sound sculpted, how can you get around, and how can I encourage musicians to be creative? How can I make it so that finding the sweet spots and the unusual things and so on, and one of the wonderful things about sampling is that if you can put in your own samples, you've now got another wild card you can throw into the deck. What I love about sampling is as an element of musicianship. The answer is it's all engineering. A tremendous amount these days is in the software. Said this at EMU, and I tell the folks at Universal Audio the same thing, that design the software not around individual features, but around a concept of an instrument and everything that musician does with it. Because if you design it around features, the competition can come in and they ask, gee, what do you like about that synthesizer? And say, well, I like this feature and this feature and this feature, and then just copy your features. It's not that hard to do. The best thing you can have your customers say is, I love my synthesizer and I can't tell you why. And people would say that about the Emu stuff, and I was very, very proud of that. That was a really neat thing. And it says we've really done our job right. That my partner Scott Wedge used to talk about how you don't want any of your features to stand out. You want everything to play together. So it isn't, it does this well, but it doesn't do these well. Or it has a lot of memory, but it doesn't have really very, very good bit depth or whatever it is. You said, you want every one of the features and specs to all be in harmony with one another so that, the instrument himself feels like an instrument rather than a collection of features.
When we designed the IK Uno Synth Pro, it was absolutely critical to us to include gate and CV I/O on the back of the unit to allow it to interface with external equipment and, of course, specifically with Eurorack systems. Dave, you've also gotten deeply involved in the Eurorack world with your company, Rossum Electro Music. You've made some really, really innovative modules, and you've sort of come full circle from, the original Emu modular all the way to the Eurorack system. What are your thoughts on the resurgence of modular synthesis and specifically the Eurorack phenomenon?
Well, the first thing I'll say about the resurgence of modular is it was in many ways surprising. Certainly, when Emu was in its decline in the 2000s, that was largely because the world of music swung towards the computer-based music, programs and apps and doing everything on your computer. At that time, I felt pretty strongly that the pendulum would at some point swing back because, to my mind, you want to have an emotional connection with your instrument. And it's very hard, at least from my picture, to have an emotional connection to a mouse and a screen. So you want, knobs you can turn and switches you can flip, and you want them to feel good. I'm considered pretty crazy in Eurorack because I will not put plastic knobs on my modules. I want metal knobs because I just like the feel of those on my finger. As I said, the degree to which the modular world has come back has really surprised me. I loved modular synths when Emu was making them in the 70s and early 80s. It felt a little esoteric, and now we find that there are so many people. And some of it, I think, is just the broad spectrum of ways to make sound that Eurorack has enabled. There are hundreds, maybe over 1,000 Eurorack manufacturers now. I can't possibly count them. From teenagers in the garage to fairly decent-sized, respectable. Everybody's respectable. I shouldn't say that word. Respectable from the Wall Street Journal. The viewpoint of businesses.
Right, like one-man shops up to actual corporations.
Yeah, exactly. And Rossum Electro is in the middle. We're a handful of crazy old people that are just having a good time doing this. What you find is that it's people who love playing with sound and music in the very broad word of what that means. Some people will ask me, what kind of music is made with modular synths? And I said, well, a lot of it you probably wouldn't even consider music. But, I consider it all music because music is what you make. It's what you want to make of it, and it's very, very personal. The wonderful thing about Eurorack, and I think this has also made it popular in the marketplace, is that the vast majority of Eurorack manufacturers realize that we aren't competing with one another. That we're really supporting one another, and that if somebody buys a Eurorack module from me and you also make Eurorack, it means they're more likely, not less likely, to buy one of your modules because they're more committed to the format. That's what I consider wonderful about Eurorack, is that whole, the spirit, the online collaboration. And it goes from people that are, complete gear nuts. How many modules can I collect? And I can't complain about that because they buy our modules. And they're enjoying it, and they're having fun with it, to some absolutely brilliant professionals. People like Hans Zimmer has got a huge Eurorack collection. He's a big fan of Rossum Electro as well, and that's pretty neat to have somebody of that stature love your modules. I think the idea of making a synth that can be plugged into Eurorack is going to open up a marketplace and again expand that musical experience. That maybe someone who is drawn to a keyboard synth because he wants a keyboard, and the Eurorack doesn't do that. If he can then buy a couple of modules and plug them onto his keyboard, he can now begin to explore that modular world. And similarly, somebody in the modular world can now have a keyboard that they can easily put in and explore that aspect of sound that they may never have wanted originally to get into keyboard music, but it's a way to dip your toe in and see, is this for me? When Rossum Electro started out, we went to a NAMM show, and this was where I reconnected with Dan. Rossum Electro we didn't really know what we were going to do. We formed the company. A lot of people said, well, you ought to get into Eurorack, but we weren't anything close to sure. We went to the NAMM show, and it was absolutely clear that was what we wanted to do. Both the community feel of all the manufacturers, and then the number of people who came up to us and said, you've got to get into Eurorack, Dave, and we'd love to have you. It was too good an experience to pass up, and that's how we got into it.
I think the Morpheus Z-Plane filter is ironically better suited to Eurorack than it was to the Proteus line of products.
Yeah, that was when we started Rossum Electro and decided to go into the modular route. There were a handful of modules that were immediately obvious. The first 4 Rossum Electro modules. The Evolution filter was an analog design, and I did this so I could do more analog design. But then the next 3 modules were all digital. Control Forge, which was a spin-off of the Emu Morpheus function generator. The Morpheus filter, exactly as you say, it was so obvious that fit into Eurorack, and people have just done wonderful things with it. And then, of course, the assimilator, bringing sampling into an entirely analog environment where, there's a little digital card that you can import your digital samples, but all of the controls on it are now analog and voltage controls. Those were all really, really fun. And then I continued to do exploration. I'll put a shameless plug here. We talked about Rossum filters, and the latest one is the Linnaeus filter, which has the crazy idea. John Chowning invented oscillators that could go through a zero frequency and a negative frequency. And I realized when thinking about doing a state variable filter that nobody had ever taken a state variable filter, either analog or digital, and swept it through zero frequency and a negative frequency. I fiddled around with it, and it sounds great. So that's another one that I think people will discover. Like, it took them a while to discover Morpheus in the early days of Emu as well. Being in the Eurorack market has been a lot of fun.
Okay, and here's the inevitable closing question. What's the future of synthesizer technology?
2020 has been a very interesting year. Our experience of business at Rossum Electro is that at first everything just shut down. We had a couple of months where we didn't sell anything. And then as people stayed at home, got bored, and wanted to do more, they started buying modules, and it's actually been a very good year for the company. The challenge is the supply lines. It's hard to keep things in stock because COVID has affected that. But, I think in answer to your question of where it's going, maybe we can take a little bit of a lesson from that the Eurorack world largely seems to have followed the social media world in that it's got people being comfortable with sharing their own amateur efforts. In many cases, just enjoying playing with sound, playing with music, not needing to be an accomplished performer to be proud of what they've done. And maybe that's some of where the future of synthesis is in allowing those people to have a further exploration of their capabilities, maybe along the other lines, getting those people to then want to go out and learn more about the technical and formal aspects of music and broaden their horizons. And synthesizers that could promote those kinds of things might be a direction one could go. We're seeing the machine learning so-called artificial intelligence world come about, you don't really see all that much of it in the music world yet. A lot of people talk to me about it. As I mentioned, I have my friend Dana Massey, who was the DSP guy at EMU and still remains a very close friend. He is now an expert in machine learning. Again, one of these brilliant that people can do everything, and I'm sure he could talk my ear off of ideas for machine learning in music. So I think that's another direction we'll see. But one of the things about all of this is that it's not just steered by the engineers; it's steered by the musicians and what they do with it. And that's, for me, that's a lot of the fun of it, is to just be surprised and take joy out of what people do with the instruments I design. Okay, I'm finally done.
That's awesome. Thank you guys so much for talking with us today. I think everyone's going to find this very interesting, and we really appreciate all of your guys' contributions to the music industry over the years, and we look forward to what you guys are going to do next.